Assalamu alaikum. So the topic related to functions, extensive topic related to function is the function transformations. So the first transformation that we shall be doing here is the translation. And for translation, what we mean is that the graph of a function can be moved either horizontally or vertically. So this kind of transformation is called translation, and it is represented along the x-axis, meaning horizontal, or it can be represented along the y-axis, meaning it can be vertical. So there are two types of translations. It can be horizontal, meaning along the x-axis, and it can be vertical, meaning it can be along the y-axis here. So the horizontal translation is represented by f of x plus a, and it's a horizontal translation which is represented by minus a. If it would have been x minus a, then just by changing the sign I could have said that this is the translation by positive a. So this means it will be moving my graph, my function graph for negative a would have moved towards left, the negative x-axis, and in this case where it says f of x minus a, then my graph would have moved towards the positive x-axis, meaning in the right direction. For vertical translation is represented by f of x plus a. So this means if my a is a positive, I'll underline this a. If my a is a positive, then it means that the graph of the function will be translated vertically in the upward direction. And if it is such that it is f of x minus a, then I would say that my graph, because of this negative a, shall be moving downwards or translated downwards vertically in the y direction. So this is what horizontal and vertical translations are. Let's start working on some examples to get the concept more clear. So question 1 says sketch the graph of the function fx equals x cube. So fx equals x cube part 1. Fx equals x cube is going to be the graph, which is the curve passing through the origin, asymptotic also. So the graph of fx equals x cube is going to be the graph which is passing through the origin, having the inflection point at the origin here. Second question said gx equals 1 by a. I need to sketch the graph of the function. Gx equals 1 by a will be asymptotic towards the x-axis and towards the y-axis, and it will be in the first and the third quadrant. Therefore, I can say that the two graphs are going to be sketched over here. Now, to transform for x minus 2. So to transform for f of x minus 2, the function fx equals x cube, which we have already drawn here, passing through the origin, it says it should be transformed for x minus 2. This means that I should be transforming it horizontally by positive 2 units, as x minus 2 equals 0, so x equals to 2. And this is what we have discussed earlier also, when we said that if it is f of x plus a, then I should be translating it in the negative horizontal direction. If it is x minus a, translated in the positive x direction. So here it says it's x of minus 2, meaning I shall be shifting it towards the positive unit, towards my right by 2 units. So from origin, shifted to 2 units, and this is how the same fx equals x cube graph shall be for f of x minus 2. Then transforming g of x equals 1 by a, and now we have to transform for g of x minus 2. I can see there is a constant over here, and the constant means that I shall be transforming it along the vertical direction, which is going to be a negative 2, meaning I shall be transforming it downwards. So initially the graph was asymptotic towards the x-axis. Now it should get translated or towards -2. So I have made this line -2. The graph is getting translated downwards by 2 units, and this is how the sketch is going to be for this function here. Now question 2 is the graph of y equals fx is transformed to the graph of y equals f of x plus 5. So describe the transformation. Y equals f of x plus 5. So I can see that y equals f of x plus 5. It is actually the horizontal transformation, and there is a positive 5 transformation or translation. Therefore, I know that this graph needs to be translated along the x-axis towards my left by -5 units. So to describe the transformation, I'll simply say that the graph is transformed or translated by -5, and there is no translation taking place in the vertical direction. Therefore, I'll say it's -5 comma 0. So this is how I will be just giving the translation over here, the translation vector over here. If, for example, my graph would have been y equals f of x plus 5, and I'm just introducing a constant which is a -2, then in this case I would say that the graph or the function is getting translated horizontally by -5 units, -5 units, and vertically by -2 units. Or in vector form, I would say that the vector is going to be -5 and a -2. We always write the horizontal translation in the first row and the vertical translation in the second row. So this is how I will be giving this translation vector here. So the third question says the curve y equals x square minus 3 is translated by -1 and a 0. So the function here is f of x, which is equals to x square minus 3, and the translation vector given to us is for -1 and 0. So one thing is very much clear, that this is getting horizontally translated. It's getting horizontally translated by -1 unit and no translation along the y-axis in the y direction. No translation in the y direction here. So if this is the case, there is just the translation along the x-axis, and that is by -1 unit. So by changing the sign, I will just say that the translated vector should be x plus 1 the whole square and a -3, and then simplifying it further, I can say this is x square plus 2x plus 1 minus 3, and the translated or the transformed function shall be having the equation as x square plus 2x and -2. So this is how we can just form the transformed equations also after certain transformations. Another example is the curve y equals x square minus x plus 1 is translated by 0, 3, no translation in the x direction, and it's a positive translation by 3 units in the y direction. So if this was the function which is x square minus x plus 1 and it's getting translated by 0 and 3, what I know is in the y direction, it's just the translation of 3 units, that is, the translation has to be with respect to the constant. So for this case, I will just say that this function shall be translated by 3 units here, and my transformed equation for f of x plus 3 this is f of x constant plus 3 shall be x square minus x plus 4, and this is going to be my transformed equation here. Sketch the graph of y equals gx where g of x equals 2 to power x. So g of x equals, it equals 2 to power x. So what I know is that 2 to power x is an exponential function, a positive exponential function, and for positive exponential function, the graph gets asymptotic towards the x-axis. So this is how the graph shall be. The only working that we shall be doing here is to find the value of this function when your x is a 0. So if my x is a 0, I can say that this gx function, which is for g of 0, shall be equal to 2 to the power 0, and 2 to the power 0 shall be equal to a 1, meaning this graph should be passing through the y-axis at 1. So this is the basic graph of the gx, which equals 2 to the power x. Second part of the question, it says on separate diagram, sketch the graph of y equals g of x plus 2. So y equals g of x plus 2. Part 1, the transformation is asked for y equals g of x plus 2. So what I know is if this is the transformation for g of x plus 2, then I should be representing it as a negative 2 and a 0. Meaning the graph that I have already sketched shall be moved towards the x-axis. This graph, I know that it should be moved towards the negative x-axis in the negative horizontal direction by 2 units. Therefore, it's a negative 2 units marked on my x-axis. And again, I need to do a little bit of working here with respect to the y-intercept and the value when your x equals a negative 2. So what happens is my graph is for the function 2 to the power x. The given function was 2 to the power x. Now if I say that this is for x plus 2, then my function becomes 2 to the power x plus 2. So in the case where my x is a 0, on the y-axis, my x is a 0, therefore my function becomes g of 0, that will be equal to 2 to the power 0 plus 2, giving me 2 square, which shall be equal to a 4 here. That means on the y-axis, my graph is going to represent a 4. In the same manner, if I have a negative 2 in place of my x, then with x as a negative 2, I should say that this is 2 to the power minus 2 plus 2. That will give me 2 to the power 0, and the answer is going to be a 1. Meaning when my x is a negative 2, my y value shall be a positive 1. So this is the little bit of working that I shall be doing for this graph here. Now the second part of this question says y equals g of x minus 1. Minus 1 is a constant. So the original graph for g of x equals to x is shown. Now if it says it should be for g of x minus 1, I know that this graph needs to be shifted downwards, so that if it gets shifted downwards, let's make it on the same graph only. I should say that this graph shall be representing this 1 unit getting moved downwards by 1 unit, and the graph now shall be negative 1. So instead of being asymptotic towards the x-axis, now it's going to be asymptotic towards negative 1. The 1 y-intercept shall move to the origin, moving down by 1 unit, and therefore the new graph shall be. So this is how the new graph shall be sketched with respect to g of x minus 1. I can see that from the x-axis, the graph was asymptotic towards the negative x-axis. Now it has moved down by 1 unit. The y-intercept was a 1 initially, moving down by 1 unit. It should be passing through the origin. And this is how my graph for g of x minus 1 shall be. Now let's do the third part. The third part says it should be g of x plus 4. So what I know here is that the transformation shall be for 0 and a positive 4, meaning the graph now has to shift by 4 units upwards. Therefore, moving it by 4 units upwards, it means now that asymptotic towards the origin, now it should be moved 4 units upwards. So this is going to be my asymptotic line towards, moved by 4 units upwards in the positive direction. 1, which was the y-intercept, now needs to be a 1 plus 4. That should be giving me a 5. Therefore, my new graph is going to be somewhat like this. So this is the graph of y equals g of x and a positive 4. So I've just moved the graph by 4 units in the upward direction. So this is what my translation for g of x plus 4 is going to be.